Hello, my name is John Derwent, and in this session I will begin the discussion of putting together the data ecosystem for an analytics project. The basis for this discussion will be a business case for a telecommunications company battling for high-value customers. After describing our case, I'll work through a few of the interesting scenarios around data and modeling. First up, the business case. A telecommunications company, telco, has the strategic goal of increasing its overall customer value. To do this, it has two frontline objectives. First, retain the right customers, and second, create more high-revenue customers. In order to achieve these objectives, the organization has asked its analytics group to create a profile of the highest revenue customers, a path to becoming high revenue, and a system to determine the best offer to give to a customer calling the call center. Before completing their analysis and creating their scoring models, the analysts need to understand all of the inputs that are available and how they can be used. In other words, they must understand the data environment. It can be made up of any number of data sources. But for an analyst, the four most important items are the following. First, the data type. Is it structured, unstructured, or a combination of the two? Second, the data format and delivery. Is there a traditional database structure, like a relational database system or an OLAP system? Or is it a non-conventional data type, for example, a flat file? Will the data come as a real-time feed or via a custom application call? In other words, how does the analyst get the data? Third is what I would call data activity. How does the data change? Is it static or dynamic? And how often is it acquired? Fourth, reporting. What information is going to be important to each stakeholder? Do they need dynamic real-time access to the results? For example, dashboards with drill down? Or can they handle static weekly reports? In the example, the telco analysts find that there are two main existing data sources. First, the customer information and demographic data. This data comes from the sign-up procedure and the marketing systems. It is a structured relational database with a fairly static data, at least on a customer level, and it has fixed fields for every customer. Second, the transaction history. This data varies more with the customer and includes all billing and payment events and dates. It is stored in the billing system, which is separate from the marketing systems, and its format is akin to time series data. Working in an enterprise environment, there are many competing priorities for data between operational and analytical uses. The operations side may rely on efficiencies of storage and loading, which may point towards flat table structures and large-scale storage appliances. IT plans and cost-benefit analysis may determine technology and data requirements. Additionally, enterprise realities such as disaster recovery point to distributed databases and fault-tolerant solutions. The analytics side of the house focuses on data structure. This calls for normalized structures with many derived attributes and consistency of field definition, cached storage for instant access, and predefined analytics schema. Technologies for ready access from analytics engines may require separate data stores and large-scale ETL processes to manage, move, and transform data prior to analysis. There is no correct answer as to which preference is better. It depends on the overall data plan for the organization. And this piece is a major component of determining how analytic an organization is, and often requires multiple departments working together. So what about other information that may be collected and available for an analysis? Recall that integrating multiple data types and points of view into a model can greatly increase predictive value and competitive edge. For example, knowing a customer's transactional history will yield some insight into future patterns. Demographic information may allow the analyst to find nearest neighbor customers, i.e., those most like this customer. Adding real-time customer activity, for example, call center notes or website activity, can yield a current state of mind. Putting those all together, and the picture becomes much more clear than if we just use one of the individual parts. Continuing the telco example, there are two possible additional data sources that will be more difficult to integrate: call center data and usage data. The The first, call center data, is stored in a CRM system and includes all form data from a call plus any live text notes entered by the agents. It is real-time data, unstructured, contains free-form text as well as customer-entered form data. Missing values and consistency of data are big issues here. The second, usage data. This data tracks location, app usage, call patterns, etc. from the phones or devices that the customer owns. The data is stored in a large-scale multidimensional database structure. A number of challenges arise for the analysts as they proceed on the project. How should they use the disparate data sets, and is it worth the effort in terms of return? Do they try to build an analytics data warehouse, or work with the data from a number of sources on a continuing basis? Is there an analytics data model that could be used against the current and future data to build consistency of analysis and ease some of the data concerns? Can free-form text add to the modeling? Does the scale of the data necessitate certain technologies? In reality, an organization will generally end up in the middle of the operational versus analytics divide. Analysts and data owners will look to different technologies to create satisfactory and beneficial solutions. New tools can help build analytics ERDs, or entity relationship definitions, and data models connecting to disparate data sources. ETL systems can move, clean, and prepare data in order to build a warehouse or data store. Real-time data acquisition can now talk with data stores or even analytics engines, so a mixture of historical, transactional, and real-time data can be used in a scoring or decision model. Analytics projects will need to include data design, technical understanding, and often cross-department cooperation alongside the standard modeling and analytics techniques. Today I spoke about a straightforward business case which has layers of complexity based on the combinations of data options available to an enterprise. As more data is gathered, more forethought is needed to make sure that the data will be valuable to the organization. As discussed in earlier sessions, more data does not always mean better information and decisions. Technologies for collection, storage, scale, and analysis currently offer far more options to the analyst and design teams. These options add to potential and value, but also require better planning, resources, and communication across all stages of analytics projects.